Il est bon, il est bon, il est en route. Ah non, il n'est pas en route. Pardon.
3, 2, 1. OK. 3, 2, 1.
To know the difference between the different types of variables is very important when you start to analyze the data. And in particular, let us look how the different types of variables are treated for building charts and tables. We are going to look at 4 different situations. The first situation is when we have a nominal variable with only one response possible. The second situation is a nominal variable with multiple responses. The third situation is the case of the ordinal variable. And finally, the last situation will be for quantitative variables. So the first case is a nominal variable, meaning a question where the possible answers are concepts. Let's say in this example, you have different colors. You have blue, yellow, green, and white. Let's assume we have asked people to indicate the color of their car. So we have the responses, the number of people who indicated that they have a blue car. You see there are 85. How many people have a yellow, green, or white car? And that is 102. Now, obviously, in this type of question, there is only a unique response, just one response. So the car is going to be either a blue car or a white car. So this is why we talk about a unique response. So this is one way that we can present the data in a table, and a chart that can go with this table would be as follows. I label it a no-brainer graph. No-brainer graph because what I mean here is that the responses are presented in the way that they appeared in the table, and this is the way that the responses appeared in the questionnaire. Now, the real question here is that we would like to make sense out of the data. So when we look at this chart, of course, we see that there are differences in responses. One outcome has 102 responses. Obviously, it is the largest responses. But don't you think a graph like this, which is based on exactly the same data, don't you agree that this type of graph is much more telling? It is already a story that unfolds. And so what has happened here is that you have just sorted the answers in decreasing order of responses. And when we have a nominal variable with a unique response, this is probably the most efficient way to present the data. Another way of presenting the data is to use what we call a pie chart. And so when the colors are sufficiently different between the different modalities, between the different responses, we see, for instance, here that the blue color of the graph, which incidentally corresponds to white in the question, we see that this is the response that has the largest area. But on the other hand, you do have to check carefully to see whether it is the blue responses or rather the green responses that have the most answers. So sometimes it's not very clear when you're using a pie chart. Pie charts are very useful when you have 2, maybe 3 answers, but once you have more than 3, 4, 5, and above, it's not always as telling as a bar chart that we have seen just before. So remember, both of them, of course, are a correct way to present the data, but the first situation, you had a chart that was telling a story. The second situation we're going to look at is when you have a question with multiple responses. What this means is that you have a question with a choice of responses, and people are allowed to indicate more than one response. In this case, the question was, what foreign language do you use in a professional environment? And people can check, let's say, for business meetings, telephone calls, business meetings abroad, and of course there can be various situations in which a foreign language is being used in a professional situation. And what you see here is that when you add the total number of responses, it is much larger than the sample size. And this is because people can check more than one response. So the sample size in this table is 690, but the total number of responses is 1,643. When you look at the percentages, you see that the percentages are calculated on the total number of responses. Je me suis trompée, je reviens. When you look at the percentages, you see that the percentages are calculated based on the sample size, not on the total number of responses. When we look at the chart that comes with the table, this would be a typical chart that would be produced. So again, you see, of course, there is one response that comes out with 67%. We can see that it is the response that receives the highest number of responses with 67%. But if I order my responses in decreasing order, I have something that tells a story at a much, at the first glance. So my story unfolds much more naturally when I present the data in such a way. Now, the thing that you certainly don't want to do is to present the responses in a pie chart, because when you present the responses in a pie chart, you assume that the total of the area equals 100%. And in this case, we have seen that it is larger than 100%. So don't use the pie chart when you have a question with multiple responses. The third situation is the situation of an ordinal variable. You remember that an ordinal variable is a nominal variable, but with a little twist, in the sense that there is a logical order in the order of responses. And so when you see such a table, you see that the first response is entirely disagree, and the last response is entirely agree. And so a normal person would expect that the response that is located in the middle of the table would be neither agree nor disagree. So it would be the kind of a neutral point. If we look at the chart, this is how the chart looks like. Now, if we were to order the chart in terms of responses, it would be the fourth response, which is somehow agree, which would come in the first position. But that doesn't make sense for somebody reading the result. So just a little reminder, when you have an ordinal scale, when you have an ordinal variable, so when the order of responses makes some sense, you leave the chart and you leave the table as is. You will not put them in order of the responses. Our final case is when we have quantitative variables. Now, what happens when we have a quantitative variable is that usually, if we take the example that is on the PowerPoint, the question would be, how much did you spend during your holiday? So we expect an amount in euros, and it is an open question. So basically, if you interview 200 people, you may very well have 200 different responses. And in this case, rather than plotting it, rather than charting it, or even building a table, a frequency table, that would not make a lot of sense, because you may have about 200 lines in your table, and the frequency will be just one, in some cases maybe two, but that would be by accident. So the way that we organize this is by creating categories. We can, je dois revenir en arrière. The way that we, excuse-moi, je reviens encore une fois en arrière. So how do we go about organizing quantitative variable? Well, first of all, what we're going to do with quantitative variables is to calculate descriptive statistics. So that would be the mean, the median, but also the variance and the standard deviation. Beyond that, if we want to show the data in a table, we will create classes of value. And we will then be able to put the results in a table and in a chart form. So to create classes of value, we will transform the initial variable in an ordinal variable. And this would be an example where we have created 3 different classes, less than 2,500, from 2,500 up to 3,999, and then more than 4,000. So in this way, we will categorize, in fact, the various individual responses from our sample into 3 separate classes. And we will have, accordingly, a graph that, a bar chart usually like this, where we have the 3 classes of value. There are other quantitative variables that we can show in a graphic form, and this is when we have something like a chronological variable. A chronological variable means that we will have a value for a specific variable that is measured at different points in time. And if we do that, for instance, what we will use then is a scatter plot. So we will plot each observation on a 2-dimensional chart. As a conclusion, so remember that first and foremost, the nature of the variable will determine what you will do with the data, how you will present it in a table form or in a chart. Now, categorical data, as you remember, they consist of both nominal variables and ordinal variables. The nominal variables correspond to variables where the various responses do not have a specific order, don't have a specific logical order, whereas the ordinal variable, on the contrary, have responses in a specific order. When we talk about quantitative variables, we distinguish between the discrete variables, so variables that can be numbered, the number of rooms in a house, the number of children in a household, they are always integer numbers, and we have continuous variables whereby you can have any value in between, let's say, 0 and infinite. So I hope you understand now how to create graphs and charts with both qualitative and quantitative variables. And it is finished. C'est une quinzaine de minutes, hein?